Today we're going to learn about time distance problems and how best to set them up in order to find a solution for this type of problems. Well, before we even start, let's remind ourselves what the relationship between time, distance, and speed was. We learned that distance was speed, s, multiplied with time. So for example, if I have 100 kilometers, I can, if I have a speed of 100 kilometers per hour and I spend 4 hours on the road, I will get 400 kilometers in total. That's the relationship between distance, speed, and time. Now, sometimes you might have to extract the speed or the time and find their unique formula. So for speed, we have distance over time, and then for time, we have distance over speed. Now let's look at our problems. The problem states that a person drove 500 kilometers from Windsor to Peterborough, and he drove it in 5.5 hours in total. So if our last row here represents the total numbers, this is 5 point, and I apologize for that scribble, 5.5 hours. Now, the problem also states that while driving 5.5 hours, the person drove 500 kilometers in total, so 500 kilometers. Now, what we do know is that one part of the trip he traveled at 100 kilometers per hour and the rest at 80 kilometers per hour. So we have two different speeds. One is 100 and one is 80. Now, we do not know how much did he travel, for how long did he travel at 100 kilometers per hour, and for how long did he travel at 80 kilometers per hour, and how many kilometers did he travel. So if we would label those as X and Y, now if I look over here, if I am choosing to isolate the time, time equals distance over speed. Well, if my distance is X and my speed is 100, then time will be X divided by 100. If my distance is Y and the speed is 80, my time will be Y over 80. Now I know that when I add these two together, I get a total of 5.5 hours. When I add these two together, I will get 500 kilometers. So let's write the two equations together. X plus Y equals 500. And that second equation is X over 100 plus Y over 80 equals 5.5. Now we have a system of equations with two variables, X and Y, that we can solve choosing one of the three methods: graphing, substitution, or elimination. Now, graphing will probably be time-consuming, and on a test you have to remember that you have other problems to get to. So let's look at substitution and elimination. Before I even decide to choose one of the two methods, let's get rid of the fractions and the decimals in the same time. Don't forget 5.5 has a denominator of 1, and we have to find the lowest common denominator, which if you look, if I have 180, it is 400, the lowest common denominator. So I have to multiply the first equation. I'm going to multiply it by 4, the second equation by 5, and that third one by 400. So it becomes 4x plus 5y over 400 equals, and it's 2200 over 400. Now I can eliminate the denominators and I'm left just with the top. So I'm going to have x plus y equals 500. Now it is up to you to choose one of the methods between substitution and elimination and decide what you want to apply in order to solve the problem. Happy solving!